So what is sleep? If we start to think about the analogy of science fiction and a spaceship, during the day, all of the energy from the spaceship is used for navigation, communication, interacting with our world. But at night time, that same amount of energy is being used, but it's diverted inwards. It goes towards life support and shields. It's exactly the same thing with sleep. During the day, we're interacting, but during the night, we're using that energy to look after our bodies and our minds. Just like with science fiction, you've got people who have got different roles. Yellow coats, red coats, blue coats. The same thing happens in sleep, but we have stages of sleep. These are called REM, or rapid eye movement sleep, and everything else is called non-REM. We further divide non-REM into 3 main stages: stage 1, stage 2, and stage 3. The reason we talk about REM and non-REM is because REM actually started, and sleep medicine started, in psychiatry. And what we know about REM is it gives us a really good insight into psychological health and our emotional health. Whereas REM takes up somewhere between 20 to 25% of the night, stage 1 actually only takes up 5% of the night. It's that transition between being awake and being asleep. Our brain is cooling down. Let's talk about stage 2 sleep, which takes up about half of the whole night. For a long time we ignored stage 2, thinking it was just a byproduct. But now we know it's actually quite vital and serves 2 main functions. And these are through 2 particular things that we see in the brain. Suddenly, brain activity gets very quick and very shallow, and that's called a sleep spindle. Alternatively, we'll see a big rise in brain activity, and then it centers out again. That's called a K complex. What we now know about those is they serve these 2 particular functions of sensory gating. Now, what do we mean by that? In essence, when there's noises or sensations, it's in our best interests to stay asleep, and so we create K complexes and spindles to keep us asleep. The other function is, of course, getting our memories ready to consolidate them. So all the things we've learned today, well, we're going to see what we need to keep. And it's during stage 2 that we determine, do I need this? Do I not need this? And so we can turn everything else that we do need into long-term memory. What about stage 3, slow wave sleep? This is where the endocrine system, the immune system, and our glucose regulatory system are really active. When we're going back to that analogy about science fiction, this is really where we're talking about life support. We're fixing, repairing, and protecting our bodies. So what happens over a typical night? We get into bed, we'll go into stage 1, then to stage 2, then to stage 3, slow wave sleep. Then we go back up into stage 2. We're checking the environment, making sure it's safe that we can carry on sleeping. After that, we can go into our first REM cycle. It takes about 90 minutes to complete a full sleep cycle, and so we'll have 5 or 6 throughout the night. What's really interesting though is the dynamics change within 2 of those particular stages. In the first part of the night, we capitalize on slow wave sleep, that's stage 3, which is great for the body. And in the last part of the night, we capitalize on REM, which is great for our emotional health and our mental health. It makes sense. In the first part of the night, we need to keep the body safe. And in the last part of the night, we need to fix and repair and protect the mind. So how does sleep actually work? The best way to describe this is by talking about a box. If you think about a box, inside the box is sleep, and sleep wants to come out. But during the daytime, we've got 6 particular hormones which are sitting on top of the box. These are called acetylcholine, norepinephrine, dopamine, serotonin, histamine and orexin, and they actively suppress sleep. Inside the box is something called GABA, and GABA builds and builds and builds in pressure until the box opens up and sleep comes forward. This gives us our first indication about some of the medications we use to help manage sleep. We've all heard about antihistamines. Imagine knocking histamine off the box, especially because histamine tends to stay on the box the longest. That's one way to increase the chances of the box opening. More recently, the drugs that we are looking at now contain orexin antagonists. What we're doing here is knocking orexin off the box because it's the heaviest of all the hormones. Inside the box, of course, we've got GABA, and this gives us another indication about the drugs we use. Benzodiazepines and benzodiazepine receptor agonists, they increase the pressure of GABA and the chances of the box opening. So we've talked about the box, but there's another important element to sleep. It's called the circadian rhythm, or the human body clock. What we know is that it waxes and wanes throughout the 24-hour cycle, and it's got two very particular points. Around 4 o'clock in the afternoon, you're actually at your hottest, and you're starting to cool down. You're putting your pajamas on. And around 4 o'clock in the morning, you're at your coldest, and you start to warm up, getting you ready for the day. There's one slight challenge with the human body clock. For most of us, it's actually longer than 24 hours. It's 24 and a quarter hours. Whilst this might present us a challenge, it also presents an opportunity because we can use light, food, and exercise in order to keep us to 24 hours. If we take light, which is the strongest cue, we will register darkness through the retina. A signal travels down the optic nerve to a part of the brain called the suprachiasmatic nucleus, the master clock. The master clock will say it's dark, tells the pineal gland to start producing melatonin, and that's the signaler for us to know it's dark and go to sleep. Putting all this together, we've got a really good theory by Borbet and his two-process model. He suggests that sleep's made up of the circadian rhythm. As we know, it waxes and wanes across the 24-hour cycle and really doesn't change irrespective of what we're doing. He also outlined something called the sleep homeostat, and this is our drive to sleep. In essence, when you wake up in the morning, you won't have a drive to sleep. But as the day progresses, further and further and further, the desire to sleep will increase. We can think about it in the same way as we think about food. If you haven't eaten, then you're going to be hungry. And the longer you go without food, the more hungry you're going to get. Just like with food, the only thing that's going to offset this sleepiness is actually going to sleep. Going back to our analogy about science fiction and the spacecraft, if we think about sleep disorders, essentially it's a hybrid state. Your body is in a state of sleep, so it's going towards life support and shields, but you're actually awake, which means that you're navigating. And that creates the problems that we see the next day. Moving beyond sleep disorder, we can talk about something called sleep health, a much broader categorization. Here, we're talking about satisfaction with sleep, alertness, the timing of our sleep, the efficiency of our sleep, and our duration of sleep. Together, these make up what we would really broadly call sleep quality. If we're talking about satisfaction with sleep, for example, we're asking ourselves a couple of hours after we've woken up, how satisfied are you with your sleep? If the answer is no, then there's an opportunity to think about what would increase that satisfaction. What about alertness? Again, we'd ask ourselves, maybe an hour or so after waking up in the morning, how alert are we? Do we need a nap? those are very good indicators of how alert we are and how that related to the sleep we had that night. What about timing? It's an interesting one. We would generally ask ourselves, if we were allowed to sleep any time we wanted, would our sleep improve? That gives us an indication of whether the timing that we're currently working to may not actually be working for us. So how do we measure sleep health? There are biological ways to do it, but really the acid test is how are you feeling? And as I've said previously, about an hour or so after waking. Why? The reason being is sometimes the transition from sleep to wakefulness isn't as smooth as we would like. We've all woken up feeling a bit groggy. It's called sleep inertia. And that's usually gone within that hour. And that's a good time then to evaluate how you're sleeping. If you're feeling tired during the day, then it's likely that there's going to be an issue with the quality, the quantity, or indeed the timing of your sleep. So how can we improve our overall sleep health? I think the first thing to do is really value and prioritize our sleep. We tend to prioritize other things over sleep, but hopefully you now understand how important it is to our health and well-being. The second thing I would say is trying to keep a regular sleep-wake schedule. Actually, it's more important to have as regular a wake time as possible. The reason being is that if we think about Borbet, both the circadian rhythm and the sleep homeostat, they tend to go in tandem in the mornings. Then we need to talk about the sleep environment. Making sure the bedroom is cool, dark, quiet, and comfortable. Even if noise or light doesn't actually wake us up, it can fragment the sleep that we're getting. And that's why we might feel a bit unrefreshed during the day. The other thing we need to talk about, of course, is electronics in the bedroom. The blue light that's produced from our phones and our tablets and our laptops, it tends to simulate light. And so that's registered as a time to be awake. There's also, of course, the issue around the interaction of our electronics in the bedroom. We're waiting for responses, we're viewing things, we're expecting things. That's going to increase our mental alertness, preventing us from getting to sleep. Finally, we're going to talk about other factors which can influence our sleep, such as aging, stress, anxiety, changes in our careers, or indeed the menopause. And these feed into all of the other modules that you'll be seeing later on.